And you can see all of these forms. Maybe not now, because during the winter these forms change their position. The berm is an important protection for the beach, because it's placed at a slightly higher elevation. Usually it's formed by loose gravel. The diameter of the particles is higher in the berm with respect to the other position of the beach. So the berm is a natural protection, which is very important. So I give you an anticipation. People here are concerned by possible erosion of the berm, because, as I said, the berm is a protection against erosion. So what they do typically during the winter, the berm, if it's eroded during the winter, during the season when you have the highest waves. So what they typically do during the winter, they go there in November, they remove the berm and place the berm landwards, because they don't want that the winter waves takes the berm away. And then, in the spring, March, April, they put the berm back. So if you go on the beaches now, you see a configuration of the beach that is markedly different with respect to what you see during summer. And this is something that I suggest you to do. Just try to go there. We are in February still, and these are nice days, and you will see that it's markedly different. And you will see that there is accumulation of sand at the limit of the beach, landward limit. And this is because they took the sand and brought the sand in a safe position. This is a way of protecting beaches, something that we will discuss later. Okay, but sometimes the berm is reached by the waves and is passed, because when you have very significant storms, the extreme storms, of course, water waves, they go above the berm and reach the highest position in the beach. So, if you take into account this process, extreme events, keep in mind, they mobilize a great amount of sediments. Extreme events, which are not the ones that shape the berm. The berm is shaped by ordinary events. Extreme events mobilize a lot of sediments. They may occur once every 20, 30, 40 years. But they bring salt water and a massive amount of sediments in the landward direction, much further up than the position of the berm. So you may expect that landward, behind the berm, you have another accumulation of sediments. Another accumulation of sediments which is caused by the very extreme storms, very extreme waves. And you expect that this second accumulation of sediments, it's more important than the berm. Important because it's originated by events that bring a lot of sediment volume landwards. Indeed, what you see up there in the figure is something called the dune, which is covered by vegetation. The dune is sediment deposition originated by extreme storms with return period meaning the frequency, 1 every 10, 20, 30 years. And the dune is a second protection. So basically the enjoyable part of the beach is between the dune and the berm, and then you have the sea. Behind the dune you start seeing trees and you start seeing houses, because, as I said, it's a safe zone. It's not reached by extreme event, if not once in 100 years. And the dune is covered by vegetation because it's placed at higher elevation, and therefore it is able to collect a significant amount of fresh water. It's a kind of vegetation that is not very developed. It's not trees, because the dune is exposed to salt, spray, salty water in forms of spray. The dune is exposed to wind, strong winds. So you don't see any tree there, because the tree would collapse with the strong winds. You see trees behind the dune, because they are repaired by the dune against the wind, and they don't get spray, salty spray. But there is some vegetation. It's a vegetation that typically is not, as I said, it's grass, it's brushes, it's a vegetation that is able to resist wind and salted spray. It's extremely important to preserve the dune, and therefore it's extremely important to preserve the vegetation, because the vegetation protects the dune against sediment transport by the winds. So it's extremely important. So one way of protecting beaches is by re-implanting vegetation on the dune. Okay, now let's see some. So the terms that I wanted to teach you today, and you have to have them very well clear, is bar, berm, dune. What is run-up? What does it mean, surf zone, breaker line? Keep in mind that the zone where you have the run-up, the up and down of water, is also called the swash zone. Swash zone. It's the zone where you have the run-up. Now let me show you a couple of pictures. Look at this picture. Okay, so you clearly see there the swash zone, where you have the run-up. It's between the limit of the water and the part that is clearly wet. And beyond the swash zone, what can you see? The berm. And it's clearly visible. It's gravel. It's gravel that is transported by the waves and then left there. Okay? This is an example of a berm. And look. If you look at this berm, you see that it's not a straight line. It's linear. It's not a straight line. And you see that there are some like bends, curves, etc. There is a reason for them. It's not by chance. And the reason is probably a particular shape of the sea bottom. The reason may be that you see some rocks over there, and therefore some submerged solid structures which originate kind of protection and exposure to waves and therefore sediment transport. It is extremely important that you gain a sensitivity to these effects and you gain the ability to understand, because when you look at the shape of the beach, you get very important information, essential information on what's going on and how the beach is evolving. And this is the kind of information that you precisely need if you are called to design a beach protection strategy. You need to understand what's going on, how evolution of the beach takes place. And there are several factors affecting the evolution of the beach. You know, you need to understand the movement of waves, you need to, so therefore it means the direction of winds. You need to understand seasonality, you need to understand the shape of the sea bottom, and to understand the human impact. It's a complex issue. It's a complex environmental process, and the way to understand these environmental processes is not to start from equations. It's not to start from mathematical theory. First of all, you have to gain a perception. The distinguishing feature of the engineer with respect to a mathematician is that the engineer is able to understand what's going on by looking at an environmental process. The mathematician has other skills, other abilities. The ability of the engineer must be to understand what's going on. In terms of, knowledge, of understanding of real facts. Okay? Once that you understood the real facts, then, of course, you need the theory to design the structures. But the first thing is to gain a perception of what's going on. So try to make this exercise, and this understanding comes from observation. If you observe and you make an effort to try to understand, you gain this sensitivity. So this is the reason why for an engineer it's important to have field trips. Precisely because if you have field trips, and if you observe, you gain this capability to understand what's going on. So what is the reason for that bend? Let's try to understand. Sometimes you may conclude that you don't understand. This is not a problem. It's not a problem. So you don't have to be discouraged if you find it hard to understand. It may, in some cases, may be simply impossible because probably the reason is something that you can't see. But still you gain your sensitivity. Now, this is an example of a dune. You see that you see some vegetation. The vegetation typically is more developed in the landward side of the dune with respect to the seaward side because it's less exposed to winds, as I said. But you can see that the dune in some cases is very high. Keep in mind that these features are natural features that develop naturally. Of course, they are impacted by several factors, several drivers, including humans. So if you go to our beaches that are very developed by humans in order to increase the attractivity for tourism, you don't see typically the dune. In some of them, yes, you can still see it, but in others, the dune, sometimes it's removed and substituted with other form of protections, like an hotel, for instance. It's a protection, because it's a protection against wind, against the spray, etc. And it's removed because they wanted to gain land for building houses, hotel, roads, etc. Which is, is something that is not wrong, but it's just different from what is natural. If you want to observe these forms, you have to go where the beaches are free. So there are several beaches here in Ravenna. If you go to the Lidi Ravennati, there are several beaches that are free and are not managed. If they are not managed, usually you can recognize the dune, the berm, whatever. Okay, but not everywhere, because if they are managed, the dune, is something that limits the accessibility to the beach. And in some cases, you will find a dune with openings, because in order to allow people to easily reach the beach, they cut openings into the dune. And try to observe what happens close to the openings. What is the behavior of vegetation? What you see on the ground. Try to observe and understand what's going on. Typically, when you cut a dune, you have some sand that propagates landward because of the wind. And so over the path where you have to walk, you see a lot of sand coming landward, and the vegetation suffers there. Okay, now I think we can go back to the previous lecture, and let me talk about structures. Let me talk about structures because, as I said, I want to start from the subject of our design. So, what happens to an engineer, to a coastal engineer? Often the coastal engineer is called by administration, by private people, by individuals who are concerned by erosion, by the beach that is evolving in a way that is causing concerns for tourism, for whatever, for recreation, for the fact that maybe they had a well providing water and at a certain time the well becomes salty. So they are being concerned and ask the coastal engineer to devise a strategy to mitigate beach erosion or to restore the beach. So you may try to mitigate the effect of an adverse impact, or you may be called to restore a situation that was cancelled out by some kind of impact. And usually you have different strategies to intervene, to preserve or to restore the form of the beach people want to achieve. And here you can see a first classification of strategies. Classification is useful because it allows you to better remember what are the possible solutions. The first is a managed retreat. Sometimes this is not an option because people say, I don't want to retreat. But in some other cases, it may be an option. So if you have erosion and you are not concerned by erosion, you can just simply move a road, for instance, landward. Because if you are concerned by the road being eroded, then you may just decide to bring it landward or whatever. So the managed retreat means that, okay, I accept that the shoreline moves in a more or less natural way, because it may be also the result of a natural evolution. You may have changes in climate, you may have changes yes, climate means changes in wind, changes in rainfall, which means that you have erosion from rainfall that changes. And the earth and the environment are continuously changing, and we need to adapt to these changes. So that's fine. I mean, we can accept that the coastline moves landward, seaward, whatever. And this is the managed retreat. Sometimes, as I said, this is not an option, especially in Italy, especially in the countries where you don't have much room. Italy is a country that is very crowded. It means that we cannot get away from rivers, from lakes, from the sea, because we have no room. And therefore, sometimes we are forced to stay there. And in particular, if you look at the Adriatic coast, it's very crowded. It's impossible to accept a managed retreat, because you have hotels, you have several structures. So sometimes this is not an option. But in some countries that are not crowded, where they have a lot of room, like also the United States, the density of people in the United States is like 1/10 of the density of people in Italy. And therefore they can manage some retreat. For instance, they often retreat far from rivers. Instead of draining the rivers and building some structures to avoid floods, they just manage to retreat. But sometimes this is not an option. Okay, so if it's not an option, we may decide to intervene to hold the line. Okay, so for instance, I may build what is called a seawall. Okay, I think there is a picture here showing a seawall. This is a seawall. Also, you see the seawall is on the left, it's not very visible here, but you can see that there is a sidewalk which is limited by a seawall. And the seawall is a protection against the waves, against erosion. And then you see a drawing up there. Okay, so this is a possibility. All the line is a seawall. Another possibility is to move the shoreline forward in the seaward direction. So we may decide, for instance, to put sand there, or to build structures that limit erosion, and therefore by limiting erosion you cause a movement of the shoreline seaward. Okay, that's fine. And then, so basically these two solutions imply a kind of, they are often called hard solutions, because they often imply building structures. So they often imply a human impact. This is why they are called hard solutions in some cases. The fourth one, called indirect measures, are also called green or gray solutions. And these indirect measures include, for instance, favoring the development of vegetation and favoring the development of ecosystems in general, or policy to control and limit the causes they may have a harmful effect. Policies like what is the source of sediments for beach? It's typically a river. And if you drain the river, like you remove sand from the river because you want to use the sand for civil engineering, structure, etc., you decrease the supply of sediments. So you may devise a policy that limits the removal of sand from the river, therefore increasing the supply of sediments to the sea. This is a solution that doesn't imply building structures. It's a green solution, what is called green solution. So basically you have three categories: is doing nothing and I simply leave, hard solutions, infrastructures, and green solutions. Okay, let's have a look. And let's talk about, a second classification. A second classification divides the measures between active and passive. Basically, active measures, they aim to hold the line and move the shoreline forward, seaward. It's called active because basically it's something that, let's say, brings the line forward. The passive measures, instead, basically they are finalized to hold the line. So this is the second classification. The active measures include what I already mentioned: breakwaters, groins, and beach nourishment. I already defined the breakwaters and groins, and beach nourishment, also called beach replenishment, means bringing sand to the beach artificially. Okay? Passive measures include seawalls and revetments. Revetments are like you bring boulders over the dune in order to avoid erosion, or boulders over the berm, again to avoid erosion. And it's like a seawall that is not made by concrete, but made by boulders or materials that looks more natural. Okay? Let me see. Here you see a Wikipedia page that is linked in my web page, so an example of seawalls. Let me see if there is an example of revetments. Okay, these are revetments. These are what are called revetments. You see, this is a kind of protection for, this is already the dune. Keep in mind that sometimes, we are talking today, I didn't emphasize this, we are talking today about beaches and not about other forms of coastline like rocky coastline. Even when you talk about beaches, some of these elements that I identified, the bar, the dune, the berm, they are not always present. I already mentioned the case of the dune that is often removed. And in this case, you see a coastline that is not really a beach, and the revetment are the direct protection of the coastline. And if it is a sandy coastline, I cannot understand from this figure, this is what I would call the dune, because it's the divide between the seaward part and the landward part. Anyway, these are revetments. Now, let's talk about these measures very briefly to understand what they are. I already gave an introduction. So, when we talk about seawalls, I'm now going to show you some figures that I borrowed from a colleague teaching coastal engineering in the center of Italy. And if you look at the symbols, the legend of the symbols that are used here, try to understand what is emerging. So basically, if you look at this symbol here, this identifies emerging structures. This is a black line, is the symbol for the original coastline. So emerging structure. With the dashed line, we identify a submerged structure. And with the continuous line and this kind of symbol, we identify the protections or protected breaks between structures. Protected means that usually we will see for each of the structures what does it mean protected break. Emerging signal is something that is useful for the boats because if you build a submerged structure, often you need to put a signal there so the boat can see that there is a submerged structure. So the symbol is clearly very easy to understand, and it's built against the original coastline, and it's emerging because, of course, an expectation that you have for a seawall is that it's higher than the highest wave. That's fine. And then here you see breakwaters, so emerging structures with protected breaks. Protected means that these breaks are protected by submerged structures that resist to erosion. Why do we need to protect the breaks? Because in the break you have a concentration of energy, of waves. Okay, so basically in the breaks you have still an erosion action by waves. And therefore, it's better if you protect the sea bottom against erosion. And protection may be done with revetments, boulders placed on the sea bottom, or sometimes with kind of floors of concrete. Usually we use boulders. So what we do when we build a breakwater is, and we decide to build it with boulders, which is by far the most used option. So here we have our, sorry, we wanted to use the black for the coastline. Here we have our coastline, and we decide to protect it against erosion, and then we decide to build a breakwater here. And another here, and we decide to leave a break. And you may say, why a break? Breaks are needed because, first of all, sometimes you need to let people go through. Maybe swimmers, maybe small boats of tourists. Also, breaks are very useful to limit the visual impact of breakwaters, because breakwaters have a very heavy visual impact. People perceive that it's something that is not natural, and there are some tourists that don't like to go in beaches that are protected by breakwaters. And also they don't like it because the lee zone has a poorer quality with respect to the seawall part. Because of course you have less oxygen, less turbulence, and sometimes you have algal flourishment, and people don't like it. So basically, if you keep some breaks, it's better for the circulation of water, for the circulation of nutrients, of oxygen, etc., and people and boats. So very often we avoid very long breakwaters and we design the presence of some breaks. But of course, a break means that you are not stopping the waves, and therefore what we do is these breakwaters are realized by just dropping big boulders starting from the sea bottom. Of course, not just casual dropping. You need to make sure that they have a shape that allows them to resist against the wave action. But basically, you drop boulders. And it is advisable that you drop some submerged boulder also in the breaks, because in this way you avoid erosion here. And it may be advisable that the protection is extended. Is extended landward, because of course otherwise you may have some long erosion there. So this is the explanation of this picture here. Backwater with protected breaks. Here you have a combination. You have first submerged breakwaters. Submerged breakwaters are a very good option because of the limited visual impact and obvious considerations. And basically, what is the submergence? With respect to the mean sea level, usually we design a submergence of about ½ meter, and this is defined as a weak submergence. And it is advisable to protect the breaks. It's advisable to put signals for the reasons that I outlined before. In this case, these are coupled with groins. And here you see a case of only groins. So, an obvious question that you should have is, what's the difference between breakwater and groins? So, when should I design a groin, or should I suggest to realize to put in place a breakwater? So let's anticipate that we have two main directions of propagation of sediments, which means propagation of sediments means erosion and deposition. The two directions are cross-shore direction. So cross-shore a second direction is along shore. So, what dictates this direction? The direction of waves. So, if you have a direction of waves, like I depict here another coastline. If you have a direction of waves, like this one, of course you have two components of the velocity of the wave. Velocity of the wave component in the cross-shore direction and along-shore direction. One may dominate over the other. Typically, you have a dominant cross-shore during extreme length, while the long shore dominates in the long term. So the long shore sediment transport is effectively in the long term. The cross-shore, this is a rule of thumb, not always valid, but a good indication. The cross-shore erosion, movement of sediment, is dominant in the short term, in the extreme, during extreme length. And therefore it's clear what's the difference between the two types of structures. The breakwater blocks the cross-shore sediment transport. The groin blocks the along-shore sediment transport. And this is why sometimes we couple them, because in this case, when the dominant direction of waves is not unique, I mean, it allows for a cross-shore and a long-shore component, then in this case we may couple the two types of structures. Okay. We will see later on how to characterize and estimate the volume of sediment transport in the two directions. Now, these are the T-groins. The T-groins are like a combination, as I mentioned before, between a protection in the cross-shore direction and a protection in the long-shore direction. And also, the T-groin is, the T is an efficient protection of the groin itself, because the T limits the erosion at the end of the groin. Okay, and this is another possible solution, small islands, which is probably less impacting from a visual point of view. So these are the structures that we will take into account. Design of breakwater is mainly taken care by Professor Archetti in the two credits that she is teaching to you now. Sorry, design of breakwater. And the design of groins, it's typical.